In the race to build artificial intelligence that thinks like humans, everyone focuses on the glamorous layer above. The algorithms, the chips, the breakthrough models that capture headlines and investor attention. But beneath this digital wonderland lies something far more fundamental. Something that could make or break the entire AI revolution. While venture capitalists pour billions into AI startups and tech giants compete for processing supremacy, a quieter battle rages below ground. Utility companies now find themselves holding keys to the kingdom. Every AI data center requires enormous amounts of electricity. More than entire cities sometimes. The infrastructure that delivers this power wasn't built for this demand. These sprawling data centers consume more electricity than small countries. Their power needs grow exponentially as AI models become more sophisticated. What appears to be a software problem is actually an electrical engineering challenge. Someone must upgrade transmission lines, substations, and distribution networks. Someone must approve connection requests and ensure grid stability. Utility planning cycles move in decades, not quarters. While AI companies want to scale operations in months, utilities must navigate complex regulatory frameworks. They balance competing demands from residential customers, industrial manufacturers, and now these power-hungry AI facilities. Each new data center represents millions of dollars in infrastructure upgrades. The permitting process alone can take years. Utilities must study load impacts, upgrade equipment, and sometimes build entirely new substations. Local infrastructure readiness varies dramatically. Some regions welcome AI development with open arms and streamlined processes. Others lack capacity or political will to support massive power demands. Cost recovery frameworks complicate matters further. Utilities must justify infrastructure investments to regulators and ratepayers. Who pays for the electrical upgrades that enable AI breakthroughs? Should residential customers subsidize tech companies' power needs? These questions determine where AI development can realistically occur. This invisible layer beneath the AI boom represents one of technology's greatest dependencies. Without reliable, abundant electricity, the most advanced algorithms remain useless. The companies that control electrical service territories suddenly find themselves as gatekeepers. Their decisions about infrastructure investment and load management shape AI's future trajectory. Consider this visual metaphor. The glamorous digital layer of artificial intelligence rests entirely upon an invisible foundation of copper and steel. Every breakthrough in machine learning depends on electrons flowing through wires installed generations ago. The speed of innovation in software now matches the pace of infrastructure development below. Geographic advantages become strategic assets. Regions with existing electrical capacity, favorable regulatory environments, and proactive utility companies attract AI investment. Other areas watch opportunities flow elsewhere. The same forces that shaped industrial development decades ago now influence artificial intelligence geography. Utility companies face unprecedented challenges. Their core mission remains delivering reliable electricity, but now they enable humanity's most ambitious computing projects. They must balance traditional customer needs with explosive demand from AI facilities. Their planning decisions affect not just local communities but global technological progress. Reliability becomes paramount. AI training runs cannot afford power interruptions. A single outage can cost millions in lost computation and damaged equipment. Utilities must guarantee unprecedented levels of service while managing aging infrastructure and extreme weather events. Climate change adds another layer of complexity to already challenging operations. Investment requirements dwarf previous infrastructure projects. Utilities need billions to upgrade distribution networks, build new transmission lines, and install advanced monitoring systems. They must convince regulators and ratepayers to support these massive expenditures. The return on investment timeline spans decades while AI development moves at lightning speed. The symbiotic relationship between artificial intelligence and electrical utilities grows stronger daily. As AI models become more powerful, their power requirements increase exponentially. Utilities must anticipate these needs years in advance. Their ability to deliver reliable, abundant electricity determines how quickly AI can advance. Smart grid technologies offer potential solutions but require massive investment. Advanced monitoring systems can optimize power delivery to AI facilities. Automated switching can redirect electricity during peak demand periods. But implementing these technologies across entire service territories takes time and resources that utilities must carefully allocate. Site selection becomes a complex dance between AI companies and utilities. Developers seek locations with adequate electrical capacity, favorable regulatory environments, and reliable grid connections. Utilities evaluate proposals based on infrastructure readiness, load impact, and cost recovery potential. The intersection of these interests determines where AI clusters form. Environmental considerations add another dimension to utility planning. AI facilities consume enormous amounts of electricity, often generated from fossil fuels. Utilities face pressure to supply clean energy while meeting growing demand. They must balance sustainability goals with reliability requirements and economic constraints. These trade-offs influence where AI development can realistically occur. The transition to renewable energy complicates utility planning further. Solar and wind generation varies with weather conditions, creating challenges for facilities requiring constant power. Utilities must develop new strategies for managing intermittent generation while maintaining grid stability. Energy storage systems become critical components of AI-ready electrical infrastructure. Long-term planning horizons extend beyond typical utility cycles. AI power demands grow exponentially as models become more sophisticated. Utilities must project these needs decades into the future while managing uncertainty about technological development. Their infrastructure investments will support AI capabilities that don't yet exist but will define tomorrow's economy. Peak demand management becomes increasingly challenging. AI facilities operate continuously at maximum capacity, creating constant high loads. Hot weather increases cooling requirements, adding to electrical demand. Utilities must ensure adequate capacity during these peak periods while maintaining reliability for all customers. The margin for error shrinks as AI loads grow. Regulatory approval processes determine project viability. Utilities must justify infrastructure investments to regulatory commissions and demonstrate public benefit. Rate impact studies show how upgrades affect residential and commercial customers. The complexity of AI-related infrastructure investments creates new challenges for traditional regulatory frameworks that weren't designed for this type of development. The convergence of artificial intelligence and electrical utilities represents a fundamental shift in technology infrastructure. What began as separate industries now operates as interconnected systems. Utilities enable AI development while AI technologies optimize electrical grid operations. This symbiotic relationship will shape technological progress for decades to come. Success requires unprecedented coordination between utilities and AI developers. Both industries must adapt traditional practices to support exponential growth. Utilities need to accelerate planning cycles and embrace new technologies. AI companies must understand electrical infrastructure constraints and work within existing systems. Their collaboration determines how quickly artificial intelligence can transform society.